Draw, that's our little squiggle. But then we need to know what's going on. We have 3 transformations, 1, 2, 3. This is the stretch. This is the movement right or left. This is up or down. So first I like to work here and find that actual vertex point. So I'm going to go, since it's positive 2, that's actually telling me on the x-axis, I'm going to go back to negative 2. And the negative 1 on the outside is telling me to go down 1. So here's where I start. And my vertical stretch tells me from this vertex point, I'm going up 3 over 1 and down 3 over 1. And then I'm going to just do my best. Oh gosh, especially on here, this is terrible. And there should look like a cubic function. Okay, a square root function typically is the library is looking like that. But I have a flip happening and I'm moving up 2. So I'm going to go directly up to 2. And because I have this flip, I would typically go up 1 over 1, but I'm going to go down 1 over 1. And then if I were to plug in any other information here, you could do that if you want a third point. I'm okay with having 2 points here. But if we plugged in 4, let's say, okay, square root of 4 is 2. So negative 2 plus 2 is 0. So if I were to go over to 4, 2, 3, 4, I'd be hitting it 0. So there would be my third point. Okay, this is strictly just a line, but it's got a negative slope, so it should be down. So I'm starting at 0, and then I'm going to go down 2 over 1. Down 2 over 1. So there's my lovely, oh wow. There's my line. All right, here we have our absolute value, but this is telling me that I have some sort of stretch, and then I'm moving down to 4. So 1, 2, 3, 4. Here's my vertex point. And my stretch, I'm going to go up 1/4 over 1. Up 1/4 over 1. And then I have a really wide looking absolute value. From 9, I have a parabola, but it's going to be flipped, and I'm going to move right. So I'm going to go right 1, 2, 3. Sorry. And then I'm going to go down 1 over 1, both sides, and make my U. And here I have my reciprocal function, but I have to move left 1 and down 2. And then you can kind of draw your asymptotes through here. So that's like my brand new origin. And then it would be normal 3 points. So there's, oh gosh, there's my function. And I would be going down 1 over 1 to the half. To the half. There we go. Okay. Moving on. Now I have to define the function if I'm given the information. So it's a square root function. There's square root. But I have to shift left 7 units. So shifting left is going to throw me negative. So I actually am going to be x plus 7, all underneath the root. And then it's reflected in the x-axis, so I'm adding a negative in front. So here's my function. Wow. Okay, cubed. So I have to shift down 3 units, shift left, and a vertical stretch of 2. So 2's in front. My shift left has to make sure that I am definitely in these parentheses. Okay, so left again is back, so I'm going to go plus 5. And then I'm down 3 units, so minus 3 on the outside. And then write the function that defines the given graph. I'm given this parabola. I know that it's going to be x squared. So I have to just ask myself what's happening. All right, so I am shifting down 4 units, but I have a normal slope, up 1 over 1. So it's just x squared minus 4. There was no shift left or right. And the last one, we have an absolute value. So what's happening here? I'm shifting back to left 2, and then I have a normal slope, and I'm not going up or down. So that shift left or right has to be inside the absolute value. So x plus 2. Wow, I just said it was a normal slope, but it's totally flipped, which is a negative in front. So sorry. There you go. And that's it.